Hi everyone. In this video, we're going to look at modeling trig functions. Now, just as a reminder, if we have a trig function in this form, then the period of this function is equal to 2 pi divided by the absolute value of k. The amplitude is equal to the absolute value of a, and the phase shift is equal to d. In this video, we're going to look at some examples where we're given different situations and we have to model it using a trig function. In this first example, a Ferris wheel has a radius of 10 meters and a person gets on the bottom of the ride at a height of 2 meters. The wheel completes a rotation every 20 seconds. We're going to want to sketch a graph of the height versus time for 2 revolutions of the Ferris wheel. Okay, so I'm going to start by drawing a sketch. The height of my Ferris wheel, that's going to go on the y-axis, and my time is going to go on my x-axis. The units for height here are in meters, and the units for time are in seconds. To help me sketch a graph of the height versus time for a person on the Ferris wheel, what will help us out is by drawing a sketch of the Ferris wheel and using the information that we're given in the problem here to help us draw the sketch of the graph. Okay, so I have a Ferris wheel here, and we know this Ferris wheel has a radius of 10 meters. A person will get on the bottom of the Ferris wheel at a height of 2 meters. And the wheel completes a rotation every 20 seconds. So that means it will take a person 20 seconds to go around the Ferris wheel once. Okay, now let's use that information to help us sketch the graph. At the very beginning, the person will start at a height of 2 meters. So that means on my graph, at 0 seconds, we're going to start at a height of 2 meters. Okay, so then the passenger is going to keep going around the Ferris wheel, and they're going to reach the top here at a height of 22 meters. And how do I know? Because they started at a height of 2 meters. The radius of this Ferris wheel is 10 meters. And if I add that again, then we'll reach the top here at a height of 22 meters. Because 2 meters plus 10 meters plus 10 meters is 22 meters. And since it takes 20 seconds to make one full rotation around the Ferris wheel, it will take half of that, so 10 seconds, to reach a height of 22 meters. Now I'm just going to plot a point here. It takes 20 seconds to go all the way around the Ferris wheel and get back to the bottom of the Ferris wheel at a height of 2 meters. And if I want to make my graph more exact, I can add some more points here as well. Because we know, okay, so say we know the time it will take to reach, to go halfway up the Ferris wheel. Well, to get to the very top of the Ferris wheel, it takes 10 seconds. So that means it'll take half of that. It'll take 5 seconds here to reach a height of 12 meters. And to go 3/4 of the way around the circle, to get back to a height of 12 meters, that will be halfway between 10 and 20 seconds. So it'll take 15 seconds to come back to reach a height of 12 meters. And now, I plotted some points here. I can connect these points with a curve to represent the height of a passenger on the Ferris wheel. Okay, so this would be the height of a passenger versus time for 1 revolution of the Ferris wheel. To sketch the height for 2 revolutions, we can just take this graph and copy it again on the right here. And there we go. We have a sketch of the height versus time for 2 revolutions of the Ferris wheel. Okay, part B. Determine an equation representing the height of a rider after t seconds. Now, let's say I want to model this equation using a sine graph. Then, the general equation for a sine graph is equal to, well, y is equal to a times sine of k times x minus d plus c. Okay. Looking at the graph, I can tell if I was to draw a line through the middle of my graph, the distance from the middle to the height, the amplitude of my graph, is 10 meters. Okay, the period of my graph, so the time it takes for the graph to repeat, was just 20 seconds. The c value, my vertical translation upwards, remember to find a vertical translation, the c value, you look, how much does the middle of your graph get shifted up or down? Here, the middle of my graph got shifted up 12 units. So my c value here is 12. And now I can use this information to help me write this equation. Okay. So y in my equation represents the height of my Ferris wheel. So I can replace y by h here. The amplitude of my graph is 10. So in front of the sine, I can put 10. To find my k value, I can use the formula period is equal to 2 pi divided by the absolute value of k. I know my period is 20. So I just need to solve this equation for k. And now, if I assume that my k value here is positive, then I can say, okay, 20 is equal to 2 pi divided by k. To solve this equation, I'm going to multiply k on both sides. On the right, k divided by k, that cancels out. And then you have 20 times k is equal to 2 pi. To get k by itself, I'm going to divide both sides by 20, and then I get k is equal to 2 pi over 20. Or which is the same thing as pi over 10. Okay, so I'm going to plug pi over 10 into my equation. The phase shift of my graph. Okay, to find the phase shift of the graph, remember, you want to look at a point on the middle of the graph. Okay, look to the right. Okay, this is a point that crosses through the middle of my sine graph. And we can see at this point, to get to this point, we need to shift our graph right 5 units. So that means the phase shift for my sine graph, d, is equal to 5. And I know my c value is 12. And there you go. We have an equation. And here, I can see my x-axis represents the time. So I can replace the x here with t, right? To keep the letters consistent with my graph. But there you go. This is an equation that represents the height of the graph over time. We just used the graph to help us come up with this equation. Okay, and now that we have the equation, okay, part C asks us to use this equation to find the height of a rider after 5 seconds. Well, to find the height, all we need to do, using our equation, is we can just plug in t is equal to 5 into my equation. And based on my graph, the answer I should get, so at a time of 5 seconds, I should get a height of 12 meters using my equation. If I don't get a height of 12 meters, that means I did something wrong. So I'm going to plug this value in. T is equal to 5 into my equation to find the height after 5 seconds. Five minus 5 is 0. So this is equal to 10 times sine of 0 plus 12. Well, the sine of 0 is just 0, so the height is equal to 12 meters after 5 seconds. Okay, let's take a look at one more example here. So, let's imagine. So the water depth in a harbor goes from 7 meters at midnight, this is called high tide, to 2 meters at 6 a.m. This is called low tide. So, part A, we want to sketch a graph of the water depth versus time for 24 hours. Okay, so I know from the question here, okay, I want to sketch the water depth. This is in meters versus time. At the very beginning. So let's say at midnight here, the height, the water depth in my harbor is 7 meters. So I'm going to sketch a point here at the beginning at 7 meters. And now I know, okay, after 6 hours for midnight, the water depth is going to reach a height of 2 meters. So what that tells me is when I'm graphing this, a convenient unit to use for time will be hours. Because I know at time 0 hours, the height is 7 meters. And then after 6 hours, at 6 a.m., the height is 2 meters. And we can keep going. So if it takes 6 meters to to reach the bottom, now if we assume that this pattern just keeps repeating over time, then eventually the water depth in the harbor will have to go back to 7 meters. And I can tell by looking at this. I can tell by looking at this. Just a pattern here. If it takes 6 hours to go from the its maximum height to its minimum depth here, then that means it should take another 6 hours to go back to the very top. So it'll take 12 hours total for it to go down, then get back up to the very top. And this process is just going to repeat, right? So if you want to sketch a graph of the water depth versus time for 24 hours, this process is just going to repeat. So after 18 hours, it's going to reach the very bottom at 2 meters. Then at 24 hours, it's going to go back to the very top at 7 meters. Next, we want to find an equation that represents the water depth after T hours. Okay, let's do it. So let's first start by identifying some of the different features of this graph. Okay, amplitude. Let's start with the amplitude. So there's a couple different ways we can find the amplitude. Okay, in the previous example, the way we found the amplitude was by just looking at the graph, right? Seeing what was the distance from the middle to the top of the graph. Another way we can do it is by using this equation for the amplitude. The maximum value of my graph is at 7 meters, and the minimum value is at 2 meters. So what I can do is I can subtract the maximum minus the minimum value and divide that by 2. 7 minus 2 is 5. Divided by 2, that gives me 5 over 2, or just 2.5. That's my amplitude. Okay. Next, okay, the period of my graph here. Well, this graph repeats every 12 hours. So I can tell the period of my graph is 12. And to find the k value using this information, well, okay, I know the formula for period. Okay, I'm going to plug in the period, which is equal to 12. And now, if I assume, okay, k is positive here, I can rearrange this equation just like I did before to solve for k. And here, if I rearrange this equation to solve for k, I'll find k is equal to 2 pi over 12, or pi over 6. Okay, next, I can find my vertical translation, my c value. Okay, last time, the last example, we saw how we could find the c value using just our graph. Another way to do it is by using this equation. The max value is 7, the minimum value is 2, and if I add these values and divide by 2, 7 plus 2 is 9, divided by 2 gives me 4.5. And now I have the information I need to help me come up with the equation for the water depth after t hours. Now, let's say I wanted to model this graph using a cosine graph, or a cosine equation, sorry. Okay. Okay, the y value is going to represent the depth of my water, d. My amplitude of this graph is 2.5. So, I can put 2.5 in front of cosine. My k value is pi over 6. My phase shift. To find the phase shift of a cosine graph, you look at the very top of the graph and see how much does it move to the left or to the right. The top of my graph doesn't move left or right at all. There is no phase shift here. So what does that mean? Okay, the phase shift is 0. There is no phase shift. So that means in my equation, d is equal to 0 here for my phase shift. And so I have, okay, the depth is equal to 2.5 cosine of pi over 6x plus my c value, which is 4.5. So I just used the properties of my graph to help me come up with the equation. Part C. I want to use my equation now to find the water depth at 2 a.m. Okay, so what do I need to do? Well, okay, 2 a.m. That's 2 hours after midnight. So if in my equation, okay, I plug in x or t is equal to 2 hours, right? This will tell me what the depth is after 2 hours. So here, let me use the letter t to make this a little bit clearer. If I plug in t is equal to 2 hours into my equation there, then I will get the depth after 2 hours. Now, I can plug this all into my calculator to figure out what the depth is after 2 hours. And remember, when you're plugging this into your calculator, make sure your calculator is in radian mode, right? Because if you put your calculator in degree mode, you will get the wrong answer. Okay, so if I plug this into my calculator, I get the depth of the water at 2 a.m. is 5.75 meters. So in this video, we looked at how we could model different situations using trig functions.